So why the relationship? We're now asked to explain why D is not linear. Well, first of all, we need to start with our physics principle, which is, what does linear mean? Something that's linear means it is of the form y equals mx plus b, where m is the slope and is constant, forming a straight line. So this is our physics principle. To be linear, it must be in this form, where m is the slope and it's constant, turning a straight line. Next we have so this is our principle. Now we have our observation, and that is a straight line. By that we mean constant slope. I'll put that in parentheses. Cannot be drawn through all the error bars. Therefore, the relationship is not linear. And so now we have our points, our principle, our observation, and our conclusion, our therefore statement, and then we would write that into it could be 3 sentences. We laid it out that way. Estimate the horizontal distance between supports A and B. So that's something we already thought through in the beginning. A and B occurs when D equals 0. Well, D equals 0 at about 0.45 or 0.47, something like that. So 0.47, and is it meters or centimeters? Meters is L when D equals 0. And so we might want to first out saying that we're looking for when D equals 0, L is the length AB. And then D from the graph, D equals 0 at L equals 0.47 meters. It's a 2-point question, so we've got to do more than just say. And next we have an experiment was carried out. It was hypothesized that D depends on the square root of L. So concretely, that means D is related to the square root of L, and D then would be equal to some proportionality constant times the square root of L. Determine whether it is valid. Using your answer to part A, whether this hypothesis is valid. So the best way for us to do this is to realize that K is a constant, and so solving for K, we get D over the square root of L. Or we could square both sides, and K squared then is D squared over L. So we could figure either of those things out. Now I recommend, usually you can get by with just 1 or 2 points. I recommend choosing several points off this. And so for the first thing is we need D, and then we need L, and then we need square root of L, and then we need D divided by the square root of L. So we need to choose some points off the graph, and those points are, let me change the label so the order makes a little more sense. We'll have L, D, L, D, square root of L, and then D over the square root of L. So L of 0.55, 0.75, 1.05, 1.35, 1.65. So that's 5 points. The D's that go along with those are 0.08, 0.26, 0.44, and 0.58, and lastly 0.75. And when we get to square root of d over the square root of L, we get 0.11, 0.30, 0.43, 0.50, and 0.58. Now, so this is supposed to be equal to k. It's supposed to be a constant, but we see it's not constant. It's also not randomly varying around a particular value. What's happening is d over the square root of L increases. It's definitely not constant. So determine using your answer to A whether this hypothesis is valid. So the first thing we're going to say is this thought process. We would say, if true, d equals k times the square root of L, and k equals d over the square root of L. Taking 5 points from the graph and computing d over the square root of L, we find that d divided by the square root of L is not constant. Therefore, d is not proportional to the square root of L. We might even add a little parenthetically here is that it increases. That's not essential, but we might add that there, that it's not constant. It's not proportional to the, and thus is not a valid hypothesis. So here's the physics principle. The physics principle we have is that if this is true, this is what's going on. Our observation, we take 5 points, blah, blah, blah. The d is not constant. And the conclusion that we have, d is not proportional to t. So those are three perhaps typical points for this question. And that's this entire question.